This is TKMaths Khan. How are you all? Today I have to come to explain to you the concept of chapter 18 of AdMaths O-Level, which is derivatives of trigonometric function. You should know that you should know derivative of 4 functions in O-Level AdMaths, which are polynomial function like x squared plus 3x plus 4. So you have done those in chapter 15. Then derivative of trigonometric function, which is in chapter 18, and we will cover it today. And then derivative of exponential function and log function, which we will cover in chapter 19 in my next video. So let's see chapter 18, derivative of trigonometric function. If y is equals to sine x, the derivative of sine x is cos x. You don't need to show the proof of it. These 3 you will learn by heart about sine, cos and tan. So let's see. Now I have written it in 2 ways just to tell you that first derivative can be expressed this way or this way, both are okay. The same question can be given like this also. Differentiate sine x with respect to x. So when it is given in this form, at times the students get confused. So you must remember it is the same thing. Either I asked differentiate y with respect to x and y is sine x. So answer is this. Whereas I can also ask in this format. Now, if I ask you or it is asked from you, what is the derivative of cos x? So derivative of cos x is minus sine x. So again you have to learn it by heart. So differentiation of sine x is cos x. Differentiation of cos x is minus sine x. Here again I have just shown you that it can be written this way or this way. The meaning is same, that you are differentiating cos x with respect to x. And answer is minus sine x. Then differentiation of tan x. So differentiation of tan x is sec square x. And again it can be written like this. The very important thing is the x is in radian. We will see its application later. So when you differentiate trigonometric function, you change the mode of the calculator into radian. So what you have learned, that differentiation of sine x is cos x, differentiation of cos x is minus sine x, and differentiation of tan x is sec square x. Now before we see few examples of exercise 18.1, I would like to tell you here that the concepts you have learned in chapter 15, 16 and 17 will be repeated in chapter 18. So I have given here a recap so that you can recall which concepts you have learned in chapter 15. So chapter 15 was about differentiation and its technique. So you learned there the concept of basic differentiation of polynomial, differentiation of a composite function, product of 2 functions, and the formula was u derivative of v plus v derivative of u. And then quotient of 2 functions, this also you have done, and equation of tangent and normal. Now, what are all these if you have forgotten? We will see in the examples of exercise 18.1. Here I am just trying to tell you or help you to recall which concepts you have learned in chapter 15. Then comes chapter 16. Chapter 16 was about rate of change. So you learned over there related rate of change, where we apply this chain rule. And the second concept we have learned in chapter 16 is a small change. Delta y over delta x equals to dy over dx. I don't know how many of you know that delta y over delta x equals to dy over dx when limit delta x approaches to 0. If you have not learned this, I'm not going into the detail of this at the moment because you don't need to mention it, but this is what is actually happening behind it in the background. So if you don't know this thing, you do not need to worry. You can just remember this for the time being, because you will apply this concept when we will talk about a small change or approximate change. Then the third concept in chapter 16 you have learned is percentage change. So when you know what is the change, either delta y, delta x, then how to change it into percentage. Just like you calculate your own percentage when you get your score in any test. So similarly, it is delta x over x into 100% or delta y over y into 100%. Then comes chapter 17, which is about higher derivative and its application. So there we learn the concept of changes in gradient, and if you want to see in detail all this, you can refer to my other video on chapter 17 or chapter 16. Anyway, so you learn there the concept of changes in gradient. You learn when they will ask or it is asked find the maximum or minimum point, you basically put rate of change equals to 0 there. Now why I have taken here 3 examples. If equation is given in terms of y and x, then it means dy over dx. If equation is given in terms of a and x, maybe a is area, x is the dimension of any shape, then you will put it equals to 0, first rate of change or first derivative, or dv over dx. Maybe the equation is given of volume of a box and its dimension. So if maximum or minimum point you have to calculate, you differentiate it and put it equals to 0, because at maximum point or minimum point or at a stationary point, the rate of change is 0. Then in chapter 17, you also learn about second derivative. Second derivative helps you to find out the nature of the turning point. By nature, we mean maximum or minimum, because at the turning point, rate of change is 0. So either it is maximum point over there or minimum. So we used second derivative. Now we have seen which concept may apply in chapter 18. So let's see in detail chapter 18 now. Okay, so when we will be solving question of chapter 18, we will come across with 3 types of trigonometric function, or I can say 3 formats of trigonometric function which you need to understand. Number 1 is simple, which I have explained earlier. Like sine x you have to differentiate, answer will be cos x. Then suppose it is given in this form. Simple x is not here, rather it is ax plus b, for example 2x plus 3. I will explain later. So in general right now. So differentiation of sine is cos. We have learned that. Differentiation of sine is cos. So it will be cos ax plus b. Now this is my angle. Just like x is my angle here, so this whole is my angle here. So the derivative of sine ax plus b will be cos ax plus b multiplied by the derivative of the angle. Now this is my angle. So derivative of this is a plus 0. So it will become a cos ax plus b, because this a will go as a multiplier. Now let's see an example of it. For example, I have y is equals to sine 3x square plus 2, and I want to differentiate it. We have just learned that differentiation of sine is cos, so it will be cos. The whole angle, this is representing one angle. The whole angle will come as it is. So first we are differentiating sine, trig, cos of the angle multiplied by the differentiation of the angle. So the differentiation of the angle will be 6x plus 0, because the derivative of 2 will be 0. So it will become 6x cos 3x square plus 2. I hope you are understanding this. Now here is the third type of trigonometric. I told you there are 3 types of equation, or 3 forms of trigonometric equation will come, and you should understand how to differentiate them. So now this is the third type, in which you will have a number here. You will have a number here like sine square, sine cube, sine power 4, and bx mean maybe 2x, 3x. We will see an example. Okay, so now in this case what happens? You handle these type of question in 3 steps. Number 1 step is you handle the power. So power will come here as a multiplier. Na sine n minus 1 bx. Now, this is not changing. Sine, whatever trigonometry ratio is here, it will not change. Trigonometric function, I mean, and angle, it will not change. Can you notice here? Then after that, you will multiply by the differentiation of trigonometric function here. It is sine here, so it will become cos bx. Angle will remain same. And then multiply by the differentiation of angle. So I'm repeating, it is happening in 3 steps. First of all, only power you will solve, then trig, then angle. So it is n time multiply by a sine n minus 1 bx. This is not changing. After that, multiply by the sine bx. Forget the power now, totally forget it. So cos bx into b. Now this b is coming because of the differentiation of the angle. So it will take this form. Now let's take an example here. Suppose I have 4 tan square 5x. I have angle, trig, and I have power. So I will handle power first. So it will become 2 times 4 is 8. I will tell you why 40 is written here. So 2 multiplied by 4, I have written here 10. 2 minus 1 is 1. 5x, angle as it is. And then differentiation of tan is sec square. So it is sec square 5x. And then multiply by the derivative of angle, which is 5. And derivative of 3 is 0, so I am writing here is 0. So now it will become 5 into 2 into 4, that's why I will get 40 here. So this is how we will solve trigonometric differentiation. Now we will see more example from the exercise. Now let's see, I have taken here one example, quite a number of examples here to make the concept clear. I have picked a first question from question 1D, which is this. Now if you see here, this is a polynomial function and this is a trig function. So if I differentiate it, 2 will come here as a multiply. So it will become 4 times 2x power 1. And differentiation of tan is sec square x. We have just learned initially. So it will be 3 sec square x. Why this 1 is here? Multiply by the derivative of angle. So differentiation of x is 1. So this is how I will get it. So now let's see the second example here. Now here we had plus sign in between. So these were two separate terms. So we were applying differentiation on both the terms. Here I will taking it as a polynomial and here as a trigonometry. Now let's see in this example, which is 2a, question 2a. What is happening? What do you think? Yes, I think you are right. Two functions are multiplying here. One is polynomial and one is trig, right? Polynomial and trig. And we know when two functions are multiplying and we have to differentiate it, we apply quotient rule here. Sorry, product rule. And this is the formula of the product rule. So my first function is u, x square. Derivative will be 2x. My second function is v, cos x. So it will be minus sin x. Because we know that differentiation of sine is cos, cos is minus sine, and tan is sec square. Okay, so after getting all these values, I will simply substitute in it and I will get this answer. Now let's see another example. Another question from exercise 18.1. This is question number 3 in which you have to show something. So now the question is saying that show that the differentiation of cosec x is equal to this thing. Right? So let's see. The differentiation of cosec x mean, if I want to rewrite it, I can say y is equals to cosec x and find dy over dx. So this has same meaning as this. Now from chapter 10, we know that cosec is the inverse of sin x. So I can write instead of cosec 1 over sine and then deal it as quotient rule. So it will become this. I hope you understand there is nothing new. V square mean this is my V, this is my U. So this will become V square V. If this is my U, number 1, the differentiation of 1 is 0 minus U, which is here, and derivative of V is sin x is cos x. So after that I am just simplifying it to get this result. Now let's see question 2C of same exercise 18.1. There is only one exercise in chapter 18 and the other one is miscellaneous. Okay, now look at this question. What do you think what is happening here? Again, two functions are multiplying. So I will take u as x plus 1 whole square. I have shown you on the right hand side here, right? And differentiation of u will be, we know from chapter 15, 2 will come here as a multiply, and then power will be subtracted, and then multiply by the differentiation of the function inside the bracket, which will be 1. So anyway, after getting all this, I will plug in the values in the product rule, and then this is what I am getting. When you get like this, you always see what is common. If I look at this term and this term, the common is x plus 1. So I am taking it common out. If you leave it like this, it will be alright, but most of the time it is expected that you simplify. And simplify mean if you can factorize it, please do so. So anyway, I have taken x plus 1i, bracket 1 out. So what is left from here? 1 time x plus 1 and cos x. Then plus sign, and what is left from here? 2 sin x. So this is how I will get my derivative. Now let's take another example, which is 4c. So we all know if we want to remove the square root sign, in the index form it become power half. So if I have to differentiate this, power half will come here as a multiplier. Function will remain same. Power will be reduced by 1. And then we will multiply by the derivative of this function, which is within the bracket. So differentiation of 2 is 0 and tan x is sec square x. And after that I am just simplifying it. So now let's see an example of 5d. So differentiation of cos is minus sine, we know that. This whole is my angle, so I am writing it as it is, because first I will differentiate trig and then I will multiply by the derivative of angle. So if you look at this angle, when I will differentiate it, I will get 2 from here and 0 from here. Why? Because this is just a constant, a number. If I had here simply 2, differentiation of 2 is 0. So this is also a number. So that's why when I differentiate it, it will become minus sine angle multiplied by the derivative of angle. So this is what I will get. Now let's take one example of quotient rule. It is from exercise question 7b. Now when you look at the question, you can immediately recognize it is quotient rule. Now I think you can understand how it is working because you have done quotient rule in chapter 15. So now this is my v and this is my u. So I have shown here the derivative here separately. Right? Can you see it? The derivative of this will be 2 will come here as a multiplier, 2 cos x. Multiply by the derivative of cos x, which will be sin x. You forget power then totally. So it is minus 2 sin x cos x, which I have written here because it is v, derivative of u minus u, derivative of v. So I am simply substituting in the formula and I will stop here.